Hey there, class. Today we're going to do section 6 of chapter 12, which is surface areas and volumes of spheres. So obviously, we're going to find surface areas and find volumes of spheres. We're also going to throw hemispheres in there. But first, we have a few vocab words we need to talk about. We see chord, radius, tangent, diameter, all things we've seen before in circles, not in spheres, and then poles and great circles. So I'm going to look for definitions I'm going to see that are similar from a circle and adapt them to a sphere. So I'm going to start off right here with this first one here. It says intersects the sphere in one point. Well, in a circle, the line that intersects a sphere in one point was a tangent, or a circle in one point, I should say, is a tangent. So that's going to be our definition for tangent. Segment from the center to the point on the sphere. Well, segment from the center to a point on the circle was radius, so this one's going to match up with radius. Segment that connects any 2 points on a sphere. Well, segment that connected 2 points in a circle was, we had diameter, we have chord. Let's set that to the side. Chord that contains center. Center, that dealt with diameter. So we're going to put that with diameter. So this one must be for chord. So what we're left with here are two definitions we haven't seen before. A plane that intersects the circle at the center and endpoints of the diameter of a great circle. Well, if great circle is one of our definitions, I'm sure that this one right here that uses great circle is not the definition for a great circle. So that must be our poles, and that must be our great circle. Go ahead and pause the video so you can get those written down. All right, let's look at surface area of a sphere. Our surface area of a sphere formula is 4 pi r squared. So let's look at our first one. Find the surface area of the sphere. It gives us a radius of 6, so we're just going to plug that in and now type it out on our calculator. So take a moment to do that. Round it to the nearest decimal point. And we end up with 452.4 centimeters squared. Surface area, it's going to be a squared. All right. Number 2, 22 is that whole diameter. So think about if that's the diameter, our radius is 11. Go ahead, you guys can plug and chug that into your formula on your own. Number 3, find the surface area if the circumference of the great circle is 5 pi meters. Well, remember our circumference formula is 2 pi r. So let's plug in 5 pi and set it equal to 2 pi r. I noticed that I have a pi on both sides, so that's going to cancel. And I get 5 equals 2 r. So divide both sides by 2, and my radius is 2.5. Now that I have that, I can go ahead and plug it into my surface area formula. 4 times pi times 2.5 squared. Type that into your calculator and see what you end up with. And we get 78.5, and our label is going to be meters squared. All right, find the surface area of a sphere if the area of the great circle is approximately 130 inches squared. All right, so great circle is a circle, and area formula for a circle is pi times our radius squared. So we're going to take 130 and set it equal to pi times the radius squared. If we want to get the radius by itself, first we need to get rid of pi. Next, what we're left with is our radius squared. How do you want to do squaring? Yeah, we're going to take the square root. So once you've done that, you find your radius, and then I want you guys to go back in and find our surface area. Before we can do our next problem, we need to finish off our volume formula. So let's look at the volume formula for a sphere. It's kind of a little different because it's 4/3 fraction times pi times our radius cubed. Now remember, to get a cubed on our calculator, we're going to use that little caret button and then type in the 3. So let's jump back to our next problem. Problem 5. Find the volume of a sphere with a great circle circumference of 18 pi centimeters. All right, so think about again, circumference is 2 pi r. So we're going to set 18 pi equal to 2 pi r. Right away, I see that I have pi on both sides that will cancel. And we're left with 18 equals 2r. So divide 18 by 2, and our radius is 9. So now we're going to plug that into our volume formula, which was 4/3. When you type that in your calculator, make sure you put parentheses around it. Times pi, and now our radius, 9 cubed. All right, so make sure that you're using parentheses when you're plugging these things in so that the right thing's getting cubed, the right thing's getting divided. And we end up with a volume of 3,053.6 centimeters. And now here's the thing, volume is cubed. Area is squared, volume is cubed. All right, let's introduce those hemispheres into the picture now. Hemisphere is half of the circle. So surface area, remember surface area for a hemisphere was 4 times pi radius squared. But because we have a hemisphere, we actually have half of that. So we're going to simplify there to 2 pi r squared. But hemisphere introduces this circle at the bottom, and we need to include that into our surface area. So we're going to add pi r squared, and that's going to represent that circle there. So add plus pi r squared. So here is our surface area formula for a hemisphere. All right. For volume, it's very similar. We're just going to take half of the surface area, or half of the volume of a sphere. So 1/2, again, when we type it in calculators, put it in parentheses, or you can divide by 2. 4/3 pi r cubed. If you want to think about it as a division, you can do 4/3 pi r cubed, take that whole thing, and then divide by 2. Same thing. All right, find the surface area of the hemisphere. So I have 2 pi, and we're given our radius, so this is great, 2.8 squared. But I have to remember to add that circle at the bottom. So we have pi times 2.8 squared. So go ahead and do those each individually if you'd like, or type it all in one. We should get really close to the same answer. It'll round to the same. I got 49.3 here and 24.6 here. So when we add those together, we get a surface area of 73.9 centimeters squared. Remember, surface area is squared. All right, volume of this hemisphere. Great thing, we're already given our radius. So we're going to do 1/2 and 4/3 pi times our radius cubed. Go ahead and do that into your calculator and come with the answer for that tomorrow. And our last problem, I'm actually going to have you guys take a look at it, try it on your own, and yes, that is a picture of one of those actual stone spheres in Costa Rica. All right, so we'll see you guys tomorrow.